Okay. One very important application of derivatives is mean value theorem. Okay.
Hmm.
There is something called Rolle's theorem. Okay.
Sir, are you sharing your screen? I
Oh,
can't see.
sorry. I am just projecting. Can you see my screen?
Yes, yes, yes.
One very important thing is Rolle's theorem. Okay. Let's say there is a function f of x. Okay.
Yes, sir.
F of x is continuous at every point of the closed interval a b. Okay. Something like this. F of x is something like this or something like this. Okay. It is
Between those
continuous.
2 points, it is always continuous.
It is always continuous in the closed interval. Okay. We will get there. We'll get to the uh, intricacies of why this closed interval, why not open interval, etc. Okay, and differentiable at every point of its interior AB. This is closed brackets. This is open brackets. Okay,
Yes, sir.
and if f of a equals to f of b, then there is at least one number c in a comma b. Again, open brackets. At which point f dash c equals to 0. Okay. So prima
Okay.
facie, what is it telling? There is a simple function like this. At f of a and f of b both are same. That means the yellow line is a horizontal line. Then, and if the function is continuous, obviously there must be some point where the slope should become equal to 0. If these two are continuous, then what should happen? If the function these two points are equal, if the function is continuous, obviously it has to go up or come down and ultimately reach this point.
Yes.
Okay, agreed. So either if it goes down, it has to come up. If it goes up, it has to come down. Or it can do multiple times going up and coming down. Okay. So the moment it changes its direction from down to up, there will be a minimum, right?
Yes, sir.
The slope will become 0. Or the moment it changes from up to down, the slope will become 0. Like this. Here, there are multiple cases where the slope is becoming 0. In this case, there is only one case. So, is there any way of connecting these 2 points with some curve whose slope doesn't become 0? There is no way, right?
No, sir.
Okay, even if you connect directly a flat line like this, what does that mean? Every point the slope is 0, right? Here,
Yes.
what is it saying? He's saying at least one point the slope is 0, which is very intuitive, right?
Yes, sir.
Okay, at least there should be at least one point where the slope is equal to 0. Now, let us get into little more details. He is saying it is in closed interval. Okay, closed interval, the function should be continuous in the closed interval. Closed interval means at A also we should know, at B also we should know.
Yes.
Okay, now why the closed interval? For example, if you don't take closed interval, if you take a graph of a function like this, okay, f of x equals to 1 by x, you know this one, right? The function is like this.
Mm.
Okay,
Yes.
at 0 we don't know the value, right?
Yes, sir.
F of 0 is infinity, we don't know the value. Okay, but in this case, if you take something like 0 comma 3, okay, 0 comma 3, f of 3 is defined, f of 0 is not defined, so the slope will never become 0 for this function, right?
Yes.
1 by x, if you do the differentiation, minus 1 by x square, right? The slope will never become 0. Okay, so the
Okay.
curve, basically what we are trying to say, this kind of curve will never become flat,
Oh.
right? Okay, with this curve will never become flat, right?
Yes, sir.
Okay, so now what is he trying to say? If f of this is not continuous, then we cannot talk about f of a equals to f of b. Okay, firstly, it is not continuous, then we cannot talk about f of a equals to f of b.
Okay.
Okay,
Yes, sir.
okay. Now, at the same time, uh, now it should be differential at every point, at every interior point, a comma b. Okay, now let's take some function like this. F of a equals to f of b. There is no flat, uh, there is no line parallel to x-axis, right? The slope is never equal to 0. I think he has drawn the graph. See here, this one.
Yes, sir.
In this function, the slope is never 0, right? This
Yes,
is
sir.
continuous. This is continuous. Here, what is it missing? It is not differentiable at every interior point. So that is this one. Okay. It should be differentiable at every interior point between A and B. Okay. In
Okay.
this case, what is happening? Here, there is no point. between A and B where the slope is equal to 0. Where is this failing? Because this is not differentiable at every point. This is continuous, but this is not differentiable. This point it is breaking. Okay,
Yes.
so that's why we are able to draw a graph which whose slope doesn't become 0, but still be able to maintain f of a equals to f of b. Agreed?
Yes, sir.
We are able to draw this graph. Okay, though it is smooth, it is not differentiable. So it is continuous, it is not differentiable. Okay, in this case also we are able to draw a graph. Okay, but we are breaking it. So here we are, this is increasing, this is decreasing because these 2 points are, there's a discontinuity, right?
Yes, sir.
There's a discontinuity. Okay. So that's why you're able to draw the graph such that the slope doesn't become 0 at any point between A and B.
So,
Okay.
sir, for all these graphs,
Hmm.
Rolle's theorem is applied or not?
This is failing Rolle's theorem, no? What is Rolle's theorem? Rolle's
That
theorem,
it
A
can be
and B is,
continuous in interval close to
right,
infinity.
right. Rolle's theorem, what are the two conditions? Condition is it should be defined at every point in the closed interval AB, including A and B. Okay. Okay. So here A and B it is defined. At every point it is defined also. See, f of x naught is also defined. At every point it is defined. Agreed?
Yes, sir.
But where is it failing? It is failing in the second test. Okay? What is that is the second test and differentiable at every point of its interior. It is failing here. Okay? It is not differentiable at x naught.
It is
Similarly,
the
here also
continuity also not there. Yes, sir.
it is. No, no, no. See here, f of x is continuous at every point. Right. Continuity is also it is failing. Differentiable also. Obviously, continuity fails means differentiability also fails.
Yes, sir.
Okay. True. This is not continuous. It is failing in continuity. It is defined on. It defined at A. It is defined at B, but it is not continuous. So this one, this is continuous. Okay. It
Hmm.
is defined at A. It is defined at B. So first part is passed here. Okay, but second part it failed. What is the second part? It is not differentiable at between A and B. Okay, ma?
Yes, sir.
Okay.
Yes.
This one failed the first part. This one. Okay, okay. This one, tell me whether it failed the first part or second part.
Since there is a break in the graph, it failed the first part. It's
First
not
part, very
continuous.
good, very good. Okay, it failed the first part because uh, it is not continuous. Okay,
Yes.
okay. It is defined on closed interval a comma b. Okay, it is defined on the closed interval a comma b. Right, f of a is known. Every points it is defined, but it is not continuous. Okay, because it is not continuous, there is a way to avoid the flip in the graph. Okay, you don't need to turn the direction of the graph. Understood?
Hmm.
So
Okay.
when do we get slope equals to 0? We change the direction of the graph, whether you go down and come up or go up and come down. So here there is a way to avoid that turning of the graph, right?
Yes, sir.
Okay, so that's why this has failed Rolle's theorem. This Rolle's theorem is not applicable here. Rolle's theorem is not applicable here. It is applicable here. Okay? No, no, no. This is not applicable here also. Why? Tell me.
So why not it? Oh, slope is different.
No, 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 no. So f of if you have to apply, then the beginning should match the ending, right? In these cases, beginnings are matching ending. F
Also,
of
it
a
can't
equals
be
to
minus one and one. Anything
so
random, it can't be.
no, no. But f of minus one is not equal to f of one. No. Rolle's
Yes,
theorem
sir.
is what? The beginning should match end. Okay, 2 points you are taking at both points. The value should be same. Where is this? This place it is failing. F of a equals to f of b.
It should
Understood?
approach the same.
So here there is no where f of a equals to f of b, right?
Mhm. Yes, sir.
Okay, so that's why this failed Rolle's theorem.
Okay.
Rolle's theorem is not applicable here also. Okay,
Okay.
okay. This case is Rolle's theorem applicable.
Yes, sir.
Okay, so here the slope at minus 1 and slope at plus 1 is not defined, but still it is applicable. Why? Because as per Rolle's theorem, it should be
Continue.
defined on close brackets AB. It is defined at minus 1, it is defined at plus 1, right? And
Yes,
at
sir.
minus 1, the value is same as plus 1. Okay? It is
Hmm.
defined. and we are concerned about differentiability. Sorry, we are concerned about the derivative in the open interval, not the closed interval. So if
Yes.
it has been closed interval, then this would fail the test. Understood? You understood the difference?
Understood.
Okay, so here it is differentiable everywhere except at -1 and 1 because the slope becomes vertical line, right?
Yes.
So that's why Rolle's theorem is talking about open interval uh, derivatives, not the closed interval derivative.
Hmm.
Okay, so it is differentiable at every point of its open interval, not the closed interval. You understood?
Yes.
Okay, so what is the importance of closed interval AB? What is the importance of continuous? What is the importance of open interval AB? And what is the importance of f of equals to f of b? Okay,
Hmm. Yes.
okay, it has to be continuous. Okay, and it has to be defined at every point AB closed interval. Okay, because if it is not defined at every point, then it breaks. If it breaks, then there is a way to avoid, right? If it breaks,
Yes.
there is a way to avoid flipping the graph or turning in the graph. Okay, or otherwise, if it is not differentiable, there is a way to avoid the turning of the graph.
Yes.
Okay, okay, but we are not so worried about its differentiability at A and B. Even though it is the slope is not equals to 0 or the slope is not defined at A and B, it doesn't matter. Okay, as long as f of A equals to f of B. That's why we did not say here. We could have said, right? We could have said that differentiable at every point in the closed interval AB.
Yes.
This person could have said, but he did not say that because that is not needed, right?
Okay.
That is
Yes.
not needed, right? Without that also we should be able to say.
Hmm.
We don't need it to be differentiable at A and B. At A
Yes.
and B, it need not be differentiable. Okay, as long as A and B it is matching, and at every other point it is differentiable, it is fine.
Okay.
Okay, ma? So this is very important rules theorem. Okay, so
Okay.
essentially what you are saying, the values at two different points are matching, then obviously there must be a point in between where the slope is equal to zero. Okay.
Okay.
Now another important theorem is mean value theorem, Lagrange's mean value theorem. Okay, this is Rolle's theorem, but it is kind of slightly slant version. Okay,
Okay.
just read this. Again, f of x is a continuous on a closed interval a comma b. Okay, here we are removing that requirement of f of a equals to f of b. Okay, f
Yes.
of a is defined, f of b is also defined. Okay, and it
Okay.
is continuous. Agreed?
Yes, sir.
But and again, differentiable between a and b. Okay, there are no spikes or corners or anything. Okay, it is continuous and it is smooth. That means it is differentiable between A and B. Now, what is saying? There is at least one point in between A and B where the slope is f of b minus f of a by b minus a. Essentially, what is saying? If you connect the first this point A and this point B, you will get this straight line, right?
Yes.
This yellow line, right? Now he's saying there must be one point in between A and B where if you draw the tangent, that slope should be equal to this secant.
Hmm.
Understood? This chord. Understood? See, f
Yes.
of b minus f of a by b minus a is what? The average slope of this curve between A and B, right? If you
Yes.
define something called average. Basically, the slope of the line connecting the starting point and ending point. If starting is A, ending is B, where we are talking about. Okay.
Hmm.
Now he is saying, the slant version is saying, if the curve is going like this or going like this, whichever the curve, there must be at least one point where the slope of the curve should be equal to this initial to final direct line.
Okay.
Okay. So you can try to draw the curve like anything. Okay. Even if you have to start at A. Okay. And you can go something like this also. Okay. But whichever way you go, then probably at this point, see, the line is becoming parallel. Okay,
Okay.
okay. So whichever way you go, at least again. So again, in the previous case, the curve has, if it goes up, it has to come down. If it is go down, it has to come up to make the same point. In this case, what will happen? You're just rotating the screen, right? This
Yes.
is the line. You're going up, then you have to come down. Or if you're going down, you have to go up. So that's why you just imagine like this. If you rotate this one slightly in this direction, this becomes Rolle's theorem, right?
Yes, sir.
Okay, so that's what you are saying. If so, what he is saying, uh, now the x-axis has become this. Okay, if you do the slightly transformation of axis, now it is saying if you have to go up, you have to come down. If you have to come down, if you are coming down, you have to go up. Okay, that's it. At some point, your slope of this one should be equal to slope of this line, AB. Okay,
Okay, sir.
this is what? This is
Mean
Lagrange's mean value theorem. Okay, same as Rolle's theorem, just that it is slant version of Rolle's theorem.
yes,
Okay, it's a slanted version of Rolle's theorem. Agreed, no?
yes,
Okay, so you understood this important piece. This important. Now this case, Rolle's theorem is not applicable, but these are the cases where Lagrange's mean value theorem is applicable. Agreed?
yes, sir.
Okay, as long as it is smooth, continuous, it is applicable. In this case, Lagrange's theorem is applicable. Okay?
Okay.
Okay, agreed. So what this roughly means is, okay, uh, so let's say car is traveling.
Hmm.
Okay, car is traveling in 8 seconds. It reached this distance. Okay, 8 seconds, 352 meters or feet or something. It has reached.
So your
Okay.
voice is muffled.
Hello, hello. Can you hear me, Amma?
Yes.
A car is traveling, and this is a distance and time graph. Okay, at zero it is at zero. At 8 seconds, it reached 352 feet. Okay, ma?
Okay, sir.
Okay, that means what is the average speed? 352 by 8.
Yes, sir.
Okay, that is the average speed. What he is saying is, as per this, uh, as per Lagrange's mean value theorem, there must be at least one place where the car is at the speed of 44 feet per second. Agree? You agree with this, no? If you are reaching 352 feet in 8 seconds, obviously your car speed should at least once be 44. If you are always lesser than 44, then you will never reach this destination, right?
Yes, sir.
Okay, if you are always greater than 352, you would have reached some other destination, right?
Yes, sir.
Okay, if you have reached this destination, means sometimes you can be slower, sometimes you can be faster, but at least you would have touched this 44 at least once. That is what he is saying.
Hmm.
Either you can go at 44 all the time, agreed,
Yes, sir.
or you could be slower sometime, which automatically means you are faster than 44 some other time and you are crossing 44 at least once. Okay,
Yes.
so that is what this physical interpretation of Lagrange's theorem or Rolle's theorem. Okay, at some point your slope should match. That means at some point your speed should match with the total average.
Understood.
Okay, at some point your speed should match. No, otherwise if it is not matching means you are not reaching the destination.
Yes, sir.
Okay, okay. So right now the reverse of this. What is he saying? Tell me.
F dash of x is 0 at
Hmm,
each point in the
hmm,
open interval,
hmm.
like at the differentiable part.
At each point of the open interval, then f of x equals to constant. Okay, that is fine, right? If its
Hmm.
slope is always zero, then obviously it's a constant function is kind of this is same. So this you know, this is fine. This and all is fine. Hmm. So these cases you can do, right? He's saying mean value theorem at which point, what is that point C? Okay, so okay, please remember A, B, and C. When you what is meant by C in mean value theorem? It is the point at which the slope is actually equal to the average slope, or the point in our point at which your average speed is equals your speed is equals to average speed, or your velocity is average velocity.
Yes, sir.
Okay, so generally, if you are given a question like this, what is that point? Then what will you do? You will find what is the average slope. Okay,
Yes.
f of 1 minus f of 0 by 1 minus 0. Okay, you differentiate this and find out at what point that slope is equal to that. Agreed?
Yes, sir.
Understood, no?
Yes.
So you will find out what is the first overall, what is the average slope. and then differentiate this and find out at what point uh, the slope is actually equal to that one. Okay, simple.
Yes, sir.
Simple. In all these cases, Rolle's theorem, Lagrange's theorem, what is that C? You might be asked that question, what is that C? You'll just find out what is that average C. Okay, in all these questions. Okay,
Okay.
now something interesting. So see here, what is saying? Rolle's theorem that between every two zeros of this one, there lies a zero of this one.
Okay.
Understood what is it trying to say?
Every two values of the first equation will have one value of the second equation.
Second value of the second, what is this one? If you see, this is the derivative of this one. Agreed?
Yes, sir.
Nx power n minus 1, this one. Okay, so let's take a simple case. Okay, let's take some equation like this. Okay, so by the way, if it is straight line, it is like this. If it is a quadratic equation that times power 2, it would be u shaped. And if it is a cubic equation, there should be two u's. Okay,
Okay, sir.
Not always, but at max two u's for a cubic equation, right?
Hmm.
Okay, if it is power 4, there can be at max 3. Okay,
Okay, sir.
if it is power 2, there should be one flip. Okay, if it is power 3, there can be at max two flips. If it is power 4, like this. Okay, so let's
Yes.
say something like this. Okay, something like this. Now, what is it saying? Between two zeros. Between two zeros. Okay, there is one zero here. There is one zero here. Okay, and we know all polynomials are continuous. Agreed?
Yes, sir.
A polynomial is always continuous. There is no case of discontinuity in a polynomial because we are just raising something, some x to the power, obviously, and you are adding all those things. They will be continuous. There is no question of dividing with some zero in polynomials, right? So
Yes, sir.
that's why there is no continuity. There is no question of discontinuity. Discontinuity happens when you are dividing with zero or something, right? In
Yes, sir.
polynomials, we'll never face that issue, right? So
Yes,
let's
sir.
say there is this n degree polynomial. Obviously, there can be n roots, right?
Hmm.
Max.
Yes, sir.
Okay, 2-degree polynomial, we can at max have two roots. Okay, n degree polynomial, we can have at max uh, how many roots? N
First
roots.
one, which one?
N degree polynomial can have at max n roots. Agreed?
Yes. Yes, sir.
2 degree will have two roots, 1 degree will have one root, 3 can have three roots. They can be same, they can be different, they can be real, they can be imaginary. That and all is fine. But they can at max have 3 degree will have at max three real roots. Agreed, ma?
Yes, sir.
N degree can have at max n real roots. Okay. In this case, let's say there are three real roots. Okay. That means what? At this between this point and this point. Okay.
Hmm.
Between this point and this point, as per Rolle's theorem, there should be some place where the slope is zero.
Okay.
Okay. Okay. So, and between this point and this point, as per Rolle's theorem, there should be at least one point, the slope is zero.
Yes, sir.
Okay. So, what does that mean? Between this point and this point, so if this function is f and f dash, let's call it some g. Okay.
Hmm.
Okay. If you between a and b, this g of c is zero, right?
Yes, sir.
Agreed. Because slope is zero. Slope is another function. G
Hmm.
of c is zero. Between this and this, g of this c is also zero. What does that mean? This c1 and this c2 are roots of this g.
Okay.
Agreed?
Yes,
Agreed
sir.
or not? What is g? G is the derivative of f. Agreed?
Yes, sir.
F is this function. G is derivative of f. And between every root of f, there is one root of g. Agreed?
Hmm. Yes, sir.
Between every AB of F, there must be some C by which theorem? By Rolle's theorem,
Rose
right?
tea. Yes,
By
sir.
Rolle's theorem, there must be at least one C1, one C2, whatever. So that's what he is talking about. Between every two zeros of this function, there lies a zero of this function. Agreed? No?
Yes, sir.
Agreed? No?
Yes.
This is very important. Okay.
Hmm.
So I think some advanced question also came on this thing. Okay.
Okay, sir.
Okay, on this understanding, based on this understanding. Okay,
Okay, sir.
uh, 20th, you see. Okay, 18, 19, just think of it.
F
There is a
double
set
dash,
of
sir, that is?
F double dash is continuous on AB. Okay, and F has three zeros in the interval. F has three zeros like this.
Okay.
Okay, so in this case only, F has three zeros and F double dash is continuous. That means F is differentiable, even F dash is also differentiable, right?
Yes, sir.
That means that also, right? Show that F dash has at least one zero, F double dash has at least one zero in AB. Agreed. So basically what we have done here, F dash has at least two zeros. Okay. By the same logic, if Z has two zeros, obviously Z dash should have at least one zero. Agreed?
Yes, sir.
Z has two zeros. So what does that mean? The graph of Z will look something like this, two zeros. Okay? This or like this or whatever. By the same logic, extend one more. Between this A and this B of G, there must be some C where derivative of G is actually equal to 0. That's what we are talking about.
Okay, sir.
Okay? Okay? So this generalization is actually this one.
Okay.
Okay?
Yes, sir.
Okay. What about 19th? Just think of 19th. Take 2 minutes and tell me. Write it down. F double dash greater than 0. So what
Yes,
does that mean?
sir.
The slope is always increasing. Okay, F double dash. What does F double dash mean?
Differentiated twice.
Differentiated twice. Okay, F double dash also means okay. Did I tell you about this concavity of graphs? Okay, I'll just tell you about F double dash also once. Okay, uh, look at this graph. This graph is always increasing. Agreed? See, this graph is always increasing. You can see my screen now.
Yes, sir. I can
Okay,
see.
this is always increasing. Agreed.
Yes,
But
sir.
in this increase also, there are two different ways of increase. See, this is one kind of increase, this is another kind of increase. Okay,
Okay.
agreed. So, e power x is always increasing. Agreed?
Yes.
Is always increasing. Logarithm x is also always increasing. Okay, but these increases are slightly different. F of x equal to x square. X square is this kind of increase, root x is this kind of increase. Okay, there is some difference between these two kinds of increasing. Okay,
Yes.
what is the difference? Here, if you see, the slope is also always increasing. Agreed?
Yes.
The slope is increasing. Here you see the slope is actually decreasing.
Okay.
Understood? Understood. Here, the slope is close to positive infinity, then it is coming down, it is coming down, it is coming down, it is becoming flat and flat, the slope. Right?
Yes, sir.
Here, the slope is becoming more and more vertical. Here, the slope is becoming more and more horizontal. Right?
Yes, sir.
Okay, so what does that mean? So we call this one where the slope is increasing, we call it concave up.
Okay.
Okay, we call this concave down. Okay,
Hmm.
here the slope is increasing. What does that mean? F double dash,
Yes.
F dash is also a function. Slope is increasing. What does that mean? F double dash
Will be greater than 0.
will be greater than zero. Okay, F dash is a function. Then that function is increasing means that function, if you call it g, g dash should be greater than zero. Okay. Here
Yes.
slope is decreasing. F dash, that is some g is decreasing. That means g dash is less than 0.
0.
Agreed?
Yes, sir.
Okay. Slope is increasing, slope is decreasing. Okay. So that is what this is about. F dash is increasing and F dash is decreasing. Concave up, concave down. Okay. Now, if it is concave up, uh, if F double dash is greater than 0, then it is concave up or otherwise it is concave down. Agreed? Say y
Yes, sir.
equals to x square. Y equal to x square, this is concave up, this is concave down. Okay, ma.
So they give both as concave up.
So concave up is F double dash greater than 0. See here, what is happening? The slope is increasing or decreasing? Ah,
Increasing on the
sorry.
right
Here both
side.
are concave up. Both are concave. Okay, you convince yourself. Why both are concave up?
So both are approaching infinity, like positive infinity.
No,
The
no, no,
both
no.
are
Both are
coming.
not approaching. See. So at this point, what is the slope? This is this line. Okay. When you come here, the slope is this line. Okay. The slope is becoming minus 100, minus 50, minus 20, minus 10, minus 5, 0. Again 1, 2, 5, 10, 50, 100 like this. Agreed?
So I have a doubt.
Tell me.
On the left side, it is decreasing, no, sir, the slope.
No. What is the slope? Slope of this line. Okay. At some point, the slope of the line is like this tangent, right?
Hmm.
What is the slope?
So,
What is the slope of this line? This is close to minus 100, right?
yes, sir.
Okay. So what is the slope of this line? This line is like kind of minus 50. Agreed?
Huh, yes, sir.
Understood. So this line
Understood.
slope, see, what is the slope of this line? This line slope is more negative than this line slope. Both are negatives. Agreed?
Yes, sir.
So both lines are negative. But this is actually becoming closer to zero. Okay. When a line is going up like this, what is happening to the slope?
It is like greater than zero.
Oh, okay. Wait. Tan 135. What is that? How much is tan 135?
Tan 135.
This is minus 1. Okay.
Huh.
Okay. Tan 120. How much is that?
Tan 120 is minus root
Minus
3.
root 3. Okay. Minus root 3 only, no?
Yes, sir.
Okay. Tan 150. How much is that?
Tan 150. So I guess minus root 3 by 3.
Minus 1 by root 3. Okay.
Okay.
Okay. So, and what about, okay. Agreed. Now, what is this value? Equals to minus 1.7 something. Okay.
Yes.
This is minus 1. What about this one?
So minus 1 by root 3.
Minus 1 by root 3.
Mm.
That is equals to
0.57.
point five seven minus 0.57 something. Right?
Yes, sir.
Okay. Now, 120 is this line. 135 is this line. 150 is this line. Agreed?
Hmm.
Okay. So this line's slope is, so what is happening when you are moving from 120 to 135 to 150? What is happening? Or you uh, are moving from, what is happening?
It is approaching like closer to the zero line.
Right. If you are moving in this direction, it is becoming zero. That's what that is happening now. See here. So when you are approaching from x from this to this, okay, at this point, the slope is more of this line. Okay,
Yes.
the slope is kind of 120. At this
Hmm.
point, the slope is more of 135. At this point, the slope is more of 150. Agreed?
Yes.
Okay, these 3 points. This is what? This is 120 slope. This is 135 slope. This is 150 slope. Okay, what is happening? The slope is decreasing.
Yes, sir.
Sorry. So the absolute value is decreasing, but absolute value is decreasing, right?
Okay. Hmm.
So absolute value is decreasing, but the slope is actually increasing. Agreed or not?
Yes, sir.
Okay, so the absolute value is 1.7. So 1.7 has become 1, has become 1.5. Okay, what does that mean?
It's decreasing the absolute value.
Absolute value is decreasing, but the slope is actually increasing. Agreed or not?
Yes, sir.
Okay, slope earlier it's a big negative to small negative to small negative kind of. Agreed?
Understood.
So the
Yes.
slope is actually increasing. Okay. Wait, I'll show you. Okay, fine. This is x square graph. Okay. If you what is the derivative of this 2x, right?
Yes, sir.
If you plot the graph, the derivative of this, what is that is 2x is this line, right?
Hmm.
So this basically what does that mean? The slope is always increasing. Agreed?
Yes, sir.
The slope here is some minus 100, minus 50, minus 10, 0, like this. Agreed? That is what we are trying to say.
Hmm.
Concave up means the slope is increasing.
Okay, sir.
Agreed, what?
Yes, sir.
Okay, so basically, when you look at some U kind of graph, that means it is concave up. Okay, when you look at some this kind of graph, what is happening here? Slope is
Concave
positive,
down.
positive, big positive, small positive, zero, and small negative, big negative. Okay,
So, sir, less than zero, concave down.
so this is the slope. What is happening here? Here, so this is kind of y equals to minus x square graph. Agreed?
Yes.
And what is the slope? Minus 2x. Okay. What does that mean? This is always decreasing. Okay.
Okay, sir.
Agreed, no?
Yes, sir.
The slope is always decreasing. Okay. That is this kind of graph. Okay.
Okay.
Concave up and concave down. Okay, ma.
Understood.
Okay. So now, okay, let's come to, so f double dash greater than 0 means what?
Concave
This
up.
concave up. F double dash less than 0 means what? It
Concave
is
down.
it is concave down. Very good. So now we understood what is concave up, what is concave down. Right. Now let's go back. Right. Now we are talking about this one. F double dash is greater than 0. What does that mean? The graph is kind of
Up.
parabola, upward facing parabola, right?
Yes, sir.
And f dash has at most 1 0. Uh, show that if f double dash is greater than 0, that means the graph is kind of parabola. Okay?
Hmm.
The graph is kind of parabola. What does that mean? So it is always increasing. It could be something like this. Either it will touch or it will not touch. Okay? And f dash has at most 1 0 between A and B. Okay?
Okay, sir.
Okay, then f dash, the agreed, no?
Yes.
Because it is, the graph is always concave up, that means it can at max touch at 2 points only.
Hmm.
Okay, that's what he's saying. At most one more zero.
Okay, sir.
Okay,
Yes, sir.
agreed, no?
Hmm.
Cubic has one zero. Same logic for f double dash less than zero. Okay, ma?
Okay, sir.
Okay. Now tell me this one, 29.
F of minus 1, no, sir. That is, can you zoom in a bit so I can't
Okay,
see?
okay. Okay. Can you see?
Yes.
F of minus 1 equals to 3. F dash x equals to 0 for all x. F of minus 1 is 3 and f dash x is 0. That means this is a horizontal line, right?
Hmm. Yes, sir.
Agreed?
Yes, sir.
Where are we? We are talking about 30th, right?
29.
29. Okay. Let's see, 29. Okay, let it be. 30th. F dash x equals to 2x. Okay,
Okay.
for all x. find f of t if f of z equals so basically you are given slope. Okay, you are given slope and you are given the initial value. You will be able to calculate. Okay,
Yes, sir.
whose derivatives are constant. Derivatives are constant means they are straight lines, right?
Hmm.
Okay,
Like 2x and
they are straight lines. Now f dash x find positive acceleration. Okay, fine. Okay, and uh, this one when the maxima minima first derivative should be uh, zero kind of thing. You would have you would know, right?
yes, sir.
Local extrema. Okay, first derivative for local extrema that you know, right?
Hmm.
F dash greater than 0 at each point, that means f is increasing. F dash less than 0, that means it is decreasing. You know this, right?
Yes, sir.
Increasing functions, decreasing functions, monotonic functions. Okay, next. Right. So now, okay, look at this. There is something like this. Okay, here there is this is the point of maximum, right? Local maximum. Agreed?
Yes,
Okay. So what is happening here? The slope is positive, it is becoming negative. Okay. Slope is changing from positive to negative. Okay.
okay.
Okay. So what does that mean? Slope is changing from positive to negative, something like this. This is positive. If I am trying to draw the graph of slope, okay. This is f, slope is z. Okay. Slope is positive and it is becoming negative. Agreed, ma? Straight
Hmm.
line. Okay. Now, what does that mean? F double dash. This is f dash. F double dash. F double dash is
Less than 0.
that is the slope of this function is negative. Agreed? F
Yes, sir.
double dash is negative. So that's why when f double dash is negative, what does that mean? This if the curve is concave down. That's why it will have a local maximum.
Okay.
Okay, understood.
Yes, sir.
Okay, so that's what we generally feel, right? F double dash less than 0. Why does it work? Because F double dash less than 0 means it is concave down. Okay, similarly, F double dash greater than 0 means it is concave up. That's why it will have
That's
a
a
maximum.
sigma.
Okay, ma? Concave up and concave down.
Okay,
Agreed.
sir.
Okay, now one thing you should be little careful here. Okay, one thing it should be you should be little careful here. Okay, you know this function x cube. Okay, why x cube you know, right? F of x equal to x cube.
Yes.
What is its derivative at x equals to 0?
At x equal to 0.
What is its derivative? F dash is 3x square, which is equal to 0, right?
Yes, sir.
But it doesn't have a minimum, right?
Hmm.
Okay. But then is it contradicting our statement that f dash is 0 but derivative is not 0? Sorry, derivative is 0 but uh, there is no minimum or maximum.
Yes, sir.
Okay, it is contradicting, no?
Hmm.
Okay, so that's why you have to be little careful here. Let me show you the theorem once again. See here, look at the theorem again. If f has a local minimum or maximum at an interior point of its defined, and if f dash is defined, then f dash equals to 0. Understood?
Hmm.
So here he is not talking about the reverse. Generally, people get confused. Okay, here he is talking about if there is a local minimum or maximum, then and derivative is also there, then it is 0. Understood? He is not saying if derivative is 0, there is local minimum or maximum. Understood? Both are
Okay, sir.
different. If there is a minimum and if there is a derivative, then it should be 0. Okay. Now
Understood.
the example that I gave, f of x equal to x cube. Okay, there is no minimum there. It is 0, but we are not talking about the reverse. The theorem guarantees what? If there is a minimum, okay, if the curve is taking a turn, that means there is a maximum. If the curve is taking a this word turn, there is a minimum. At that point, the slope will be 0. That's what he is saying. Okay, he
Understood.
is not talking about a curve like f of x equal to x cube. Okay,
Okay, sir.
if the logic is simple here. If the curve is taking a turn, then the slope is zero. He is not saying if the slope is zero, curve is taking a turn. Okay,
Under- mhm.
okay. So this in this case, what is happening? X cube, the curve is taking a turn, but it is not coming down. It is becoming flat and going up.
Hmm.
Okay, so that's why it is not contradicting anything. Okay, so that's why here, right, in mathematics, you should be very particular about the statements. Okay, you should take only the literal meaning.
Hmm.
What there is, whatever is written, we are supposed to read that as it is written. Okay, ma?
Hmm.
Okay, so I think this there must be some question on this. Let me just see. Okay. See this one, 79.
A minimum with no derivative.
Explain. Can you explain with this? Is it consistent with theorem 2 or not? F of x is a minimum. Okay, and f is not differentiable. Agreed? At x equals to 0.
Yes, sir.
But we have just said if there is a minimum, then the slope should be 0. Where is it failing?
They're saying that slope is not there.
Here, but f of x as a minimum, right? The
Yes,
mod x
sir.
as a minimum at x equals to 0. Agreed?
Hmm.
Okay, and but in this theorem, to what is saying, there is a minimum, then that slope should be equal to 0, right?
Yes, sir.
If f is a local minimum and maximum at an interior point, okay, and if f dash is defined, then this is 0. So where is it failing? It is failing here.
Yes, sir.
Okay, f dash is not defined.
Oh,
Okay, f dash is not defined. That's why the theorem is not applicable here.
understood.
Okay, if f dash is defined, then we would have made it this equals to 0. For example, this would be applicable for f of x equal to x square.
Hmm.
Okay, x square has a minimum at 0, right? And the
Yes.
slope is defined. That's why it is equal to 0.
Okay, sir.
Okay, this one. Can you tell about this one? Odd function. This has a minimum at x equals to c. Okay, or first do for even function. Even function x equals to c. Okay, so there is
Maximum.
some maximum. Okay, so because it is even, it looks something like this, similar, right?
Hmm.
So here also there should be a maximum. Agreed?
Yes, sir.
Okay. So now we take the odd function. Odd function, what is saying? He has got
Hmm.
uh, local minimum at x equals to c. Okay, something like this. Okay, or in fact you can take the sine graph only. Easy one. Okay, it has got a minimum uh, at x equals to c. Okay,
Then x is equal to minus c also.
x equals to c. It has got a minimum. What is this one? This is 3 pi by 2, right? Minus
Hmm.
3 pi by 2. What it will have? This piece versus this piece. Okay, understood.
Hmm.
Okay, this because this is odd function, right?
Hmm.
Agreed, no? So
Okay,
if it
sir.
has got a minimum here, it is a maximum there. Okay, ma?
Okay, sir.
Understood, no? Anything interesting? Okay, so this is called there is something called a critical point. Okay,
Hmm.
so what is the critical point? See here, whether f dash equals to 0 or f dash is not defined. Okay, that is a critical point. So for example, then the slope is 0 or slope is not defined. Okay,
Hmm.
these both are critical. Slope is 0 or slope is undefined. Okay, these are called critical points.
Okay.
Okay, now the function. Now this theorem one says if as long as slope is defined, as long as it has a local minimum or maximum, uh, this is equals to 0. Okay, now where all points the maximum can exist between we are given 2 points, either the maximum or minimum can exist at the end points, or when the slope is equal to 0. That's what he's saying. When the slope is equals to 0, or slope is not defined, or at end points. Agreed?
Yes, sir.
Agreed. So for example, if there is a function like this, okay, the function like this. Okay, the maximum is here. Okay, but the slope is not equal to 0. Agreed?
Yes, sir.
So, but the maximum is here. Agreed?
Hmm.
Okay, so but in a function like this, the maximum is here, where the slope is 0. Okay, interior points is f dash. This is the case of 1. Okay,
Okay, sir.
okay. Endpoints. This is the case of 3. Endpoint. This endpoint. That endpoint. Okay,
Hmm.
okay. Or you will get this case interior points where f dash is not defined. So for example, this case f dash is not defined. Agreed?
Hmm. Yes, sir.
Okay, so you can have maximums at these points. Basically, if you have to find the maximum of a function, what you have to do? You have to take all the cases where f dash equals to 0. You have to take to end. You have to take the endpoints, or you have to take to all the cases where f dash is not defined. In all these three places, you evaluate the function to find out what is the maximum. Okay. Generally, in most cases, you will get the reverse. Okay. In most cases, for practical cases, you will just directly do differentiation and find out equals to 0 to find out what is that this one. Most generally, you will find something like this. Okay.
Okay, sir.
Understood. That's what you generally see in our books also. You do differentiation and make it equal to 0 to find the extremum. Okay. But in fact, what is the real thing? If there is an extremum, there the derivative is 0. Okay.
Hmm. Okay,
It's
sir.
not the other way. Okay.
Understood.
Understood, no?
Yes.
And so this mean value theorem and this thing that you have done, concave up, concave down, you know, right?
Yes.
Okay, so when a function becomes from concave up to concave down, or f double dash is changing direction, or it's changing positive to negative, we call that as point of inflection. So, for example, sin x. Okay, it is definitely changing from concave down to concave up, right?
Hmm.
Agreed? It is definitely changing, no? It
Yes,
is
sir.
concave down here, concave up here. So at some point, obviously, this f double dash is changing. Okay? That is called point of inflection. Okay? So please remember, f dash equals to 0, that is that is critical point. Okay? This is point of inflection. Okay, ma?
Yes, sir. Understood.
Point of inflection is where f double dash changes sign. Critical point is where f dash changes sign. Okay?
Hmm.
So this is point of inflection. Okay?
Okay, sir.
So at point of inflection, either f double dash is 0 or f double dash doesn't exist. Like earlier, f dash is either 0, it doesn't exist at critical point. Okay, not the other way around. Okay, it's please note, if f double dash is 0, that doesn't mean that is this thing. Okay,
Hmm.
okay. If there is a point of inflection, that place f double dash is equals to 0. See here, f double dash is 0. Okay, x y equal to x power 4. Agreed.
Yes, sir.
But here it is not a point of inflection, right? It is always concave up. Agreed?
Hmm.
But what here we are saying, if it is concave, so if it is a point of inflection, f double dash equals to 0. So that is this one.
Okay.
Okay? If there is a point of inflection, what is point of inflection? When you are changing from concave up to down or down to up, whatever. Okay, ma?
Okay, sir.
Okay. So this is about mean value theorem and this thing, Rolle's theorem and mean value theorem. Okay.
Okay, sir.
Now, what you do, okay, you try to finish off your differentiability, all those 300 questions, ma?
Okay,
Okay,
sir.
differentiability, all those 300 questions, and then what else you have? Application of derivatives, you can start. Okay,
Hmm.
application of derivatives, one is this kind of rules theorem, mean value theorem, application of derivatives will be there.
Hmm.
Okay, and at the same time, how many questions are there in application of derivatives?
So almost all same for all.
300.
Hmm.
Application of derivatives also.
Yes, sir.
Okay, so application of derivatives mostly would be on the related rates or this mean value theorems. Okay,
I'll
mean
try
value
to complete all the questions in mean
all
value.
the questions. Okay, just send me the questions also. I just want to see what kind of questions that you have. Just send me Not all questions, the PYQs kind of questions, the level 2, level 3 kind of questions.
Okay, so 1 minute.